from chemistry point of view, what is very interesting and exciting in this research is to make something very new with very new property, starting from very simple ingredients like vegetable oil, for instance, and urea, which are natural products and available in huge quantity. And it is always frustrating for the chemist to make very lengthy multi-step reactions and to be able just to have NMR spectrum or very little quantity of material. Here we are able to make sample, we can play with these samples, we can show them to non-scientific people, and we can communicate our enthusiasm to non-scientists who are understanding what is the new potentiality of this research and imagine themselves application for this material. The size of this batch is about 170 grams, which is a lot in a chemistry research laboratory. And after the end of this reaction, this sample will be washed using a separatory funnel like this. So here we will separate the sample from excess amine, which will be extracted by water. So after several washings with water, this material will be reacted in the second step with urea.
We start with fatty acids, which are well known. We start with urea, and we synthesize the thing which has this extraordinary self-healing properties.
In this reactor, we now perform the second step of our preparation. So now the material will be reacted with urea, and as a result, the molecules will bear functional groups able to form very strong hydrogen bonds. As a result, the molecules will be able to associate to form the rubber. Now, the reaction is almost finished. In approximately 1 hour, we will get something similar to a piece of chewing gum. Still, it's able to flow because the temperature is high, so hydrogen bonds are dissociated and the material is able to flow like liquid, a very viscous liquid, but a liquid. After cooling, the molecules will associate through hydrogen bonds and form a network, and this network will be able to show rubber-like properties.
What's really exciting about it is that usually when you do a new chemistry, you do it on a milligram scale, and then the scale-up will be to have a gram scale of your material. Here we started right away with 100 grams and made the molecules that never existed, and they are not catalogued in any book of abstract and things like that. And so this is very exciting. The other exciting thing is that it shows that you can start with these three functional groups and do some very different chemistry on it. And so it may be renewed the interest of people to this sort of more old-fashioned type of chemistry, and shows that it can still be interesting. So it's an interesting starting material from fundamental point of view. And of course, from industry point of view, it's a very interesting one to start with too, because it has plenty of advantages, including price, which is always important. The good thing is that because of the simplicity of this technology, these materials will be available very soon, and products based on this technology will hopefully be available for people with imagination.